Welcome back, everyone. Write an appropriate Lewis structure for the species CH₃NO₂, or nitromethane. Our first step whenever we want to draw a Lewis structure for a compound is to calculate the number of valence electrons present in our structure. In this case, we have one carbon, which contributes 4 valence electrons, 3 hydrogen atoms, each of them contributes 1 electron, and then nitrogen, which contributes 5 valence electrons, 2 oxygen atoms, which contribute 6 valence electrons each. We know these numbers from the periodic table, right? Because the number of valence electrons is found from the group A number. Well done. So if we do the math, we end up with the total number of valence electrons. That would be 24. Our next step is to usually assign a central atom. But in this case, we have an organic molecule. We will have 2 central atoms, carbon and nitrogen, due to the fact that there are 2 oxygen atoms, which are more electronegative than nitrogen, and hydrogen atoms, which can only be bonded to carbon in this case to satisfy the octet rule. In addition to that, because it's an organic structure, it tells us the bonding in it. So CH3 would be a methyl group. And then we have NO2, which is a nitro group. So carbon will be directly bonded to nitrogen. Due to the fact that carbon must have 4 bonds, we already have 3 hydrogens bonded to it. So definitely we will have a CN bond in the structure. Our next step is to draw single bonds between our central atoms and terminal atoms. So what we're going to do here is simply add the remaining atoms. Let's draw our CN bond. Then we're going to draw 3 hydrogen atoms bonded to carbon. We know that because it's given in the name, CH3, right? And nitrogen will have 2 oxygen atoms, so we're going to draw 2 single bonded oxygen atoms for now. Our fourth step is to satisfy the octet rule for the terminal atoms. In other words, we're not worried about the central atoms yet. We just want to make sure that we add our electrons to the terminal atoms. Hydrogens follow the duet rule, so we don't need to worry about them. We simply want to add 3 lone pairs to each oxygen, because each oxygen already has 2 electrons from the bond. Now our next step is to calculate the remaining number of valence electrons that are not assigned. So first of all, if we calculate the number of electrons present, we have 1, 2, 3, 4, 5, 6 bonds. So that'd be 6 multiplied by 12. First of all, let's write down that the number of valence electrons unassigned. And we are going to take our original number, 24, minus, as we said, we have 6 bonds, so that'd be 6 multiplied by 2, and then we're going to subtract our lone pair electrons, so that's another 6 multiplied by 2, which gives us no electrons unassigned, meaning none of our central atoms will get any lone pair. But now we want to make sure that we also satisfy the octet rule for our central atoms. Carbon has an octet, it has 4 bonds, nitrogen has 3 bonds only. And that means we're going to take one of the lone pairs from oxygen and form a pi bond out of it to make sure that nitrogen gets an octet. Because any of the 2 oxygen atoms can be used, we will of course get resonance structures. Well done, so we got an octet on nitrogen. And of course we can show that we can do that 2 ways. One of the ways is to use the lone pair from one oxygen. So let's modify our lone pairs in a better angle. And then another structure can be obtained by using that lone pair from the other oxygen. So we are simply going to remove that lone pair and draw a double bond. And of course, our next step is to calculate the formal charges. Now, carbon has 4 bonds, meaning it will have no formal charge. Each hydrogen has 1 bond, of course, no formal charge. Now, oxygen and nitrogen, this is where we have to pause and think. So step number 7 is to recall the formal charge formula. The number of valence electrons minus the number of bonds minus the number of lone pair electrons. Starting with nitrogen, 5 because it belongs to group 5A, 4 bonds, no lone pairs. That gives us a formal positive charge. Formal charge on the single bonded oxygen, you may already guess, that'd be 6 minus 1 bond minus 6 lone pair electrons. That's -1. Apparently the structure has no net charge, so the other oxygen will have a formal charge of 0. Apparently that's true because there are 2 bonds and 2 lone pairs. So there's no necessity to worry about an additional calculation, but you of course can perform it if you want. But now we are ready to add our formal charges and get our final answer. So if we want to draw a Lewis structure correctly, we are first of all going to add our resonance arrow once again. And now we are going to add a formal positive charge on nitrogen in each case because it has 4 bonds and no lone pairs, of course. And now each single bonded oxygen will have a formal negative charge. Well done. We have successfully obtained our Lewis structures for nitromethane. Thank you for watching, and I hope to see you in the next video.